Good morning, students. In this lecture, we are going to discuss about how to analyze the sequential circuit. We are going to draw a simple sequential circuit. Now you give we have given one example sequential circuit. So here we are you think about that one. We are having two flip-flop. The two flip-flop is connected with the common clock. Two flip-flop is connected with the common clock, right? So this is the D flip-flop. So the T flip-flop is whatever the zero. If you are giving clock, zero is the output. One, if you are giving clock, then one is the output, right? So this is the characteristic of T flip-flop, right? Now you consider we are first you draw two flip-flop, right? So the two flip-flop is here a D flip-flop. Then we are having a common clock. Common clock is connected with, right? Right. So connect with common clock, right? So the clock is here. We are giving the clock pulse. That one will be right. Then the first input is connected with two AND gate. The two AND gate output is connected with one OR gate, right? Two AND gate, the output is connected with OR gate, right? Here, in the two AND gates, the first AND gate input is here the feedback of that output of first T flip flop, right? Feedback of that output of first T flip flop. The first T flip flop is going to give, and then here we are having one external input X. X is to input, right? Then here we are having second flip flop output, also going to have a feedback path to AND gate, right? Next, here you have to draw that one, the A dash, right? So that first flip flop inverted output, the complement output is going to have connected with one AND gate, and then the external input, right? So that is connected with the T flip flop. Then the external output we have to get now here OR gate with the here we are having two output, right? A as well as B, and then we are making the knot of that one, right? So that is we have to draw with AND gate. So you thorough with the circuit. So in that circuit, how do you remember that one? We have to draw two flip flop. That two flip flop we are having now connected with the common clock pulse, and that first flip flop input is, so this is the input of first T flip flop, right? So how do you get now? Or otherwise, you think about the state, right? Characteristic equation. So that characteristic equation we want to have, right? Actually, this is a reverse. This is a circuit. Then from that circuit, we find out the characteristic. So first, you should know how do you draw that circuit, right? So output of that first flip flop. First flip flop output is going to have with one AND gate, and the internal the input X is going to connect with the another AND one AND gate, right? Then another AND gate also we are having X, and also the second flip flop output as a feedback path. So that is we are having. So this is actually we are having now. This is AX. This is AX, right? So that is A and X and gate. So we are getting now AX. Then this is B and connected with AND gate. So BX. So you remember this is AX, this is BX. So output of that A and external input X. Here output of the B and external input X. So AX, BX with OR gate. So we are giving now that input is AX plus BX as a input. So whatever the input we are getting now that as output. So this is AX plus BX. Similarly, here we are having now this is A dash. A dash is that one as the complement of the first flip flop, A dash, and then X. So X. So this is we are having now A dash X. A dash X. So A dash X is input of the next flip flop. Right? Then the output, how do you get now? Here, T flip flop path, T flip flop output, and the P flip flop output is and R with. So here we are having A and B. A plus A, this is B, Right, so this is A, this is B. So we are having OR gate A plus B. A plus B. Then here we are having X. X is inverted, X dash. So here the AND. A plus B into X dash. A plus B into X dash is output. So we are having now, first you have to draw the characteristic equation. First you draw the diagram and then you have to write the characteristic equation, right? So A of t plus 1. So this is the A of t plus 1. A of t plus 1 is depends on that end. So this is the A of t. So this one has AX plus BX input. This is, we are having that characteristic equation. Next for P of t plus 1. So B is, we are getting now that one, right? A dash X. B is getting now, we are having now A dash X. Right. A dash X. So that A dash X is the second. And then here we are having separate output line. So that one is, we are having now that one as Y equal to A plus B X. Right. So this is A, this is B, this is A. So A plus B we are getting now through OR gate. And then this X is inverted. So X bar we are getting now. So we are having that one A plus B X bar. Now, second step is you have to find out characteristic equation. Suppose they may give that circuit and you have to analyze the sequential circuit. Then you find out the characteristic equation of A, B, and Y. So the characteristic equation you have to find, right? Next, you have to draw the state table. So here the state table for T flip-flop, right? So that is A. A is 0, B is 0. If you are applying X is 0, right? So applying X is 0. A is 0, B is 0, X is 0. So that one has here A 0, B 0, X also 0. So you will get now that one as 0. Then what about B? The A is 0 and X is 0. X is 0 is here 1. 0, 1, that's 0 only. Right? Then next we are having now X is 0, right? A is 0, X is 0. And we are getting now the 0 only, right? Then if you are having 1, X is 1. X is 1, right? Then we are having now, this is the A dash. A dash is A is 0. Then A dash is 1. X also 1. We are getting now the result is 1 for X equal to 1. For A 0 itself, right? Then the corresponding output for that cases, right? So A0, B0, then X bar A0, B0, so A plus B is 0. So you are getting whatever the X value, then 0 only is the Y output, right? Next, we are having, suppose we are having that input is 0, 1. The A value is 0 and B value is 1, right? All possible cases for AB. And if output, then we have to use the equation to fill the table. Use the equation now. Then in that equation, we have to put the corresponding value. Then we are getting now the corresponding value, right? So A0, B1, then we are having that AB is 1, 1. How it is? X equal to 1, right? So X equal to 1. So this is 1, 1. So we are getting now this value is 1. X is 1. Then here X is 1. Then we are having now that one as X is 1. And here A dash also 1. Then we are having now A dash also 1. So we are getting now that value is 1, 1, 1. Right? So like you have to find out the state table. Then the state diagram. How do you get the state diagram, right? So that is, here we are having 4 states, 0, 0, 0, 1, 1, 0, 1, 1. For each state, you have to draw the circle. Each state we draw the circle, right? So from the 0, if you are giving that value X is 0, then A also 0, B also 0. So this is here. X is 0, the Y is also 0, and the state also 0, 0 itself. So you have to draw the edge. So the state is not changing by input X equal to 0. So by input X is 0, the state is 0, 0, 0, 0 combination state, right? So the same state is repeated. So you have to draw the edge as well as the output is 0. So input is X, the output is 0, the state is same one. Next, we are having 0, 0. The input is 1, then output is 0, 1. So input is 1, right? Then output is 0, 1. Input is 1. The change of state is 0, 1. The output is 0 itself. So here this is output 0. You draw the edge. Next, here 0, 1. From the 0, 1, if you are giving the 0 is input, then it will go back to 0, 0. So this is case. 0 input, it will go back to 0, 0, but the output is 1. So the output is 1, right? So this is x bar y. X is input 0, then output is 1. So you have to draw the edge. Like you have to draw all edges in the state diagram. So from the sequential circuit, so you see the sequential circuit, you analyze the sequential circuit, and you get the characteristic equation. Then you have to find out the state table by present state AB, and you have to give the all possible combination. For that all possible combination, we have to derive that value from the characteristic equation. We are drawing the state table. From the state table, then we can have the state diagram. So 0, 0 to 0, 0 itself. So 0, 0 to 0, 0 itself, then input is X, output is Y, then 0. Right? Then similarly here from here another one example from 1, 1. So you think about that one from 1, 1. By input X, it will go to 0, 0. How do you get that one? As through characteristic equation 0, 0, right? Then 1, 1 to 0, 0 by input 0, then output is 1. So this is X, this is Y. So you are drawing the edge from 1, 1 to 0, 0. So 1, 1 to 0, 0 by input X, the output is 1. So this is the line you have to draw, edge you have to draw, and then you have to write the label is 0 bar 1. So this is state diagram. Suppose they may ask question about, you assume one simple sequential circuit, then from that circuit, how do you get that characteristic equation? Then from the characteristic equation, you have to find out the state table. Then from the state table, we have to draw the state diagram. Some question they will ask now that these are all the possible derivation we have to derive. That's all. We'll stop here. We'll continue by next lecture.